Welcome to Virtualizing SharePoint Performance and Availability. I'm Demir Brisnick. I'm a Senior Platform Advisor here at Microsoft Canada. And please feel free to jot down my email address and Twitter handle in case you want to follow me, or if you have any questions after that particular event. But I will be happy to take questions as well as I'm going through. So the objectives for this particular session is to take a look at how you can configure virtualization environments properly to support SharePoint. So a lot of folks out there that I talk to understand how to configure SharePoint properly, and the people that do virtualization understand how to configure virtualization environments. But in a lot of cases, the combination of the two is somewhat challenging for folks. And what I'm hoping to do in this particular session is to really give you a good idea of what are some of the ground rules for virtualizing SharePoint. Also, we'll talk about how to implement high availability features in virtual environments that support both SQL Server and SharePoint. And really what I want you to take away from this particular session is that all SharePoint roles can in fact be virtualized, and they really should be virtualized, and also that if you do in fact implement virtualization, it can increase availability and make your SharePoint environment more robust. So I did actually make some assumptions when I created this particular session. One is that you all know how to deploy SharePoint on physical servers and have got good experience in doing that, and that hopefully at some point in time you've done a basic installation of Hyper-V on Windows Server 2008 R2 and have created a virtual machine. If you're also working with VMware, just understanding how to actually create a VMware virtual machine will also work. And also you and your customers are currently working with Windows Server 2008 R2 Hyper-V and/or VMware and are using those for virtualization environments. Some of the things to really keep in mind, and one of the key fundamental things to keep in mind, is that when you're architecting SharePoint in any infrastructure, you want to make sure you follow the SharePoint rules first and make sure that you're doing the right things for SharePoint. So how to architect SharePoint is really critical here, and then once you figure that part out, then you can take a look at how you actually implement that in a virtualized environment. So the rules for implementing SharePoint and for architecting a SharePoint infrastructure don't actually change when you go virtual. They still apply. It's just how you implement those and how you actually place the SharePoint infrastructure on top of a virtual environment. That's something you have to take advantage of. Also, most of what I'm talking about is going to apply to both Hyper-V and VMware. Obviously, I'm going to spend a little bit more time on Hyper-V because I work for Microsoft and that's what I know. But a lot of the same rules, in fact, apply, especially when I get into the best practice session in terms of how you properly allocate resources. I do also want you to keep in mind that, from our perspective, Hyper-V is the best platform to run Microsoft workloads, including SharePoint, and that's true today in Windows Server 2008 R2 SP1, and it's only going to get better with Windows Server 8 Hyper-V, which got released in beta form a few days ago. So, key things to keep in mind with regards to virtualization of any workload, including SharePoint, is that when you're creating virtual machines, use the most recent operating system for those guest virtual machines. That means for SharePoint, what you want to make sure you do is that every single host that is running SharePoint, every single virtual machine that's running SharePoint is in fact running Windows Server 2008 R2 because that's the most recent operating system supported by SharePoint 2010. The other thing to keep in mind is once you actually do virtualize an environment, management of that environment becomes very, very critical. I always tell the story of this customer that they started off with about 37 physical servers in their environment. They decided to virtualize and got down to 4 physical servers and everything else virtualized. But within about 6 months, they realized they had over 100 virtual machines on those 4 physical servers. And then they were trying to figure out how to actually manage all of those workloads. Managing a virtual machine is really no different than managing a physical machine. You still have to go and do the proper things. You got to do patching, got to make sure the antivirus is updated and so on. So you want to make sure you got the right management tools to be able to go ahead and do that. And from our perspective, those tools are the System Center product line, especially the new System Center 2012 tools. If you are in fact virtualizing on a platform other than Hyper-V, keep in mind that you want to make sure that that platform that you're virtualizing on is part of the Windows Server Virtualization Validation Program. Because if they are, so VMware, for example, is part of that particular program, it means that if you have an issue with the virtualization platform or with Windows or with SharePoint, we're going to support you all the way through, and we'll work with that vendor to make sure that actually ends up happening. Also, keep in mind licensing rules for Windows Server when you are virtualizing those particular operating systems. So, when you purchase a copy of Windows Server 2008 R2 Enterprise Edition, you get the right to run that particular operating system on one piece of physical hardware, but you also can run 4 virtual machines with Windows Server on them as part of that particular license on the same host. And for data center, that's actually unlimited, but for standard edition, you're only allowed to run 1 virtual machine for free from an operating system licensing perspective, and you have to purchase additional operating system licenses if you run more than 1 VM. And this applies to all virtualization software. It doesn't matter whether that's Hyper-V or VMware, you still have to buy the Windows licenses, and the same rules do in fact apply. But don't forget SharePoint licensing as well, because whether you're running SharePoint on a virtual environment or a physical environment, the licensing rules for SharePoint don't change. So today, SharePoint 2010 licenses apply equally to a virtualized edition of SharePoint or one that's running on physical hardware, so do in fact keep that in mind. So the question I always get is, okay, which SharePoint role should I virtualize? Are they all equally good candidates for virtualization? And the reality is all of them can be, but you need to understand exactly how they're working. So if you look at the kind of the 5 typical roles that you have in a SharePoint environment, the web or front end role, the query role for basically processing search queries, the application role, so things like performance point services and so on, the indexing or search engine role that goes out and actually manages the index and crawls it, or the database role, some of these are in fact ideal candidates for virtualization. I don't think any organization today should have any web front-end servers for the SharePoint environment that are running on physical hardware. Every single one of those really are phenomenal candidates for virtualization. If you have a separate query role, that's also a great candidate for virtualization. Again, it will have a particular amount of storage it's going to need to keep local to make sure that it's got the most recent information it can serve customers quickly. But at the same time, you do want to make sure that you have that virtualized. In a lot of cases, also application server roles like performance point services and so on, Excel services can in fact be virtualized. So let's just dig a little bit deeper into this, right? So the web role, if you look at the 4 key resources on the top right-hand corner there that any particular either physical or virtual machine is dealing with, whether that's CPU, RAM, disk, or network, a web role, when you look at its utilization of these resources, will have relatively heavy RAM utilization. It'll have relatively heavy network utilization because it's serving and receiving requests from customers. Not too much disk activity, and depending upon what it's doing, it may have some amount of CPU activity. So since it's responsible for rendering content, this is actually an ideal role to go ahead and virtualize. One of the things to keep in mind as well is you want to have multiple web roles in your SharePoint environment, and if you're going to virtualize them, you want to have those virtual machines on different physical servers. I had one customer kind of virtualize their environment and say, yeah, we have a great infrastructure. We've got our search servers over here and it's virtualized, and on this other host we have all 6 of our front ends. Well, don't do that. If that one server goes down, your entire front-end infrastructure does in fact go away. So you want to make sure you take those web front-end roles and have them dispersed amongst your different physical servers that are running virtualization, and also implement either hardware-based or software-based network load balancing. If you're using Windows network load balancing at the software level, keep in mind that actually will in fact increase the CPU and network overhead on the web front end, so just monitor that. Whereas if you offload the network load balancing to a third-party hardware-based device, you actually won't get that as much as possible. And again, please make sure you split your web front ends over at least a couple of physical hosts. If you are using Windows network load balancing and Hyper-V, one of the things that you actually need to keep in mind is that you want to make sure that you're not going to end up essentially tying your web front end to the MAC address of the host that it's on. So this allows you, this particular setting here, to enable spoofing of MAC addresses will allow you to ensure the network load balancing works correctly. And that way, if you live migrate a virtual machine that's a network load balanced one from one particular Hyper-V host to another, things will still work correctly, and also you're not going to end up finding yourself tied to a specific host. So again, using the enable spoofing of MAC addresses will ensure the virtual switch will not learn the MAC address, and this is a requirement for network load balancing to work correctly in Windows environments. The query role, which is sometimes separated from the web front-end role, although in a lot of cases it's also on the exact same box, is there to process search queries. It will actually require a propagated copy of the index, so anywhere from 10 to 30% of the total size of the documents that are indexed. And really, the idea here is if you're going to actually have large indexes, you want to make sure that the storage for those indexes is in fact in a form that's going to be very well performing. So either that's going to be as on a central storage area network as a physical LAN there, or using a fixed size virtual hard disk, which is going to be a pre-configured amount of disk space for the virtual machine's virtual hard disk, and that's actually going to give you very, very good performance. So the other thing to keep in mind as well, if you're going to have an index server and a query server using the exact same storage infrastructure, keep them off keep them off the same physical disk. So have your index server using one set of physical disk and have your query server using a different set, so that way that reduces contention. Okay? And again, depending upon your environment, you can either combine or split the web query role. It really depends upon what makes sense for your environment. But for this one, it's more RAM, disk, and network intensive than it's going to be CPU intensive. But you may want to combine those web query roles into one. The index server role or the search server role is one of the ones that typically we get into interesting discussions, because these particular SharePoint servers can in fact be relatively CPU intensive, they can be memory intensive, they can be disk intensive, and they can require a fair bit of network activity as they're going to go and respond to client queries but also go out and crawling. So if you're going to have a virtualized index server role, and there's no reason why you can't do that, make sure you give it a sufficient amount of RAM so that it can do what it needs to do. And also make sure that you've got a really, really fast set of disks underneath that. So either storage on a central storage area network using iSCSI or fiber channel. But if you're going to actually have a virtualized index server, you definitely want to have iSCSI connectivity, because the virtual machine can only connect to an iSCSI SAN as a centralized storage location. The other option is to use what we call fixed size VHDs that are actually stored on a SAN, and those are also going to give you good performance, because fixed size VHDs will give you basically they're about 2 to 3% slower than raw physical disks, but that's still relatively quick, and they're very, very well performing. Application server roles, a lot of it is it depends. I mean, if that particular role has got heavy-duty disk I/O, it's got heavy-duty memory, it's got heavy-duty CPU, you may want to consider it. But in most cases, I have yet to find an application server role such as Excel services or Performance Point services or any of these others that actually can't be virtualized. So, the other nice benefit of being able to split these roles off in a virtualized environment is that when you do have specific application servers that are going to run in their own virtual machine, it reduces the amount of complexity should anything in fact go wrong. So it's easier to go ahead and add additional servers to the farm, and it's at the same time there's no additional hardware required in order to go ahead and do that when you virtualize it. The big question always comes up about SQL Server, right? So should I virtualize my SQL Server? And the reality is, well, yes, you probably should, but it also depends upon a number of factors. SQL Server 2005, 2008, 2008, R2, 2012, all fully support virtualization. But SQL Server itself can be memory intensive, it can be disk intensive, and it can be network intensive as well, and will utilize as much RAM as you possibly give it. So it's one of the reasons that a lot of organizations say, well, I want to keep it physical. And keeping it physical is also, very often the argument for that as well. SQL Server today is also a consolidation point, because all my SharePoint databases do in fact use the exact same SQL Server itself. Okay, that makes sense. I mean, that's fine. But the reality is that if you do virtualize SQL Server, you could potentially end up having multiple SQL servers around that service a particular subset of your SharePoint infrastructure. Also, SQL Server licensing in virtualization environments is in fact a little bit more liberal, where you can in fact have multiple SQL servers on a physical host that could be running in different virtual machines, and again with the operating system license giving you some usage rights there. SQL Server also, depending upon whether you license it for the physical machine or virtual machines, can give you some capability to run multiple instances as well. The reality here is it really depends upon how big that SQL Server infrastructure is and what you're doing with it, but there's no reason why you cannot actually virtualize SQL Server. And from a performance perspective, when you're using things like fixed size VHDs or iSCSI SANs, you actually will get really, really good performance, and doesn't necessarily become an issue for why you should or should not virtualize your SQL Server environment. So if you do decide to virtualize it, give it as much RAM as you possibly can. So offload disk I/O from the virtual machine. So again, use fixed size VHD or physical London iSCSI SAN so that you get the best overall performance. Again, you can also think about taking advantage of something called guest clustering, where you have SQL servers running in virtual machines, and within those virtual machines you configure a failover cluster. That way, if any one of those VMs has an issue or the host that it's on has an issue, SQL Server can fail over to the other one that's running on a different host. So it's a good way to protect that entire infrastructure. Also keep in mind that SQL database mirroring is another way of being able to ensure that you can fail over to another SQL Server instance if your primary one goes down. So that's fully supported in SharePoint 2010, unless you actually are using basically offloading some of the blob storage onto the NTFS partition, in which case you can't actually do that. So once you virtualize your SharePoint infrastructure, what are some of the considerations for performance? And when I talk about performance, I really am talking about those 4 key resources that all virtual machines have to manage, which is CPU, memory, disk, and network. So for each of those, there are some rules that are going to give you the best overall performance in your environment. So if we start off with the CPU side of things, on the physical machine, okay, you have to keep in mind that performance is essentially governed by a number of factors that really are kind of mechanical ones, dealing with things like the power of the CPU, the thermal efficiency, and so on down the line. What you typically want is hopefully a faster processor rather than potentially a more efficient one, because those more efficient ones obviously are going to have lower overall cost of operation because they use less electricity, but at the same time they will not necessarily perform the way you want. Also, if you do in fact have at the hardware level in the BIOS of the server that you're running some smarts that allow the BIOS and the hardware itself to control CPU efficiency, you want to try and turn those off, because they can in fact interfere with Windows doing the exact same thing, because Windows as a Hyper-V host has a lot of that capability built into it as well. Okay. You definitely want to have more CPUs in a box, and you want to have multi-cores as much as possible. And with the modern set of processors available today, you can also enable multi-threading, which will give you even better performance and more execution of threads at the exact same time. And again, make sure that any add-in cards that you're using, such as RAID controllers and so on, are using a PCI Express bus for best overall utilization as well. So that's the physical side of things. When you do create a virtual machine that you're going to run on that particular physical hardware, one of the things to keep in mind is that the best overall performance is if for every single core you have at the physical level, you actually map a single virtual CPU. So if you're going to create a virtual machine that's going to have 2 CPUs in it, that should actually map to 2 cores on the physical box. And if your physical box has 16 cores total, all the virtual machines together and the CPUs allocated to them shouldn't actually exceed more than 16. That's kind of the best overall practice. The reality in Hyper-V in 2008 R2 will actually support an 8-to-1. So you can have 8 virtual CPUs to 1 physical, but once you're doing that, obviously your time slicing and that in fact is going to potentially have a negative performance impact. So best overall, do a 1-to-1 mapping of virtual CPU to physical CPU. Again, be aware of the virtual processor limits for different guest operating systems. Hyper-V in Windows Server 2008 R2 supports up to 4 virtual CPUs per virtual machine. Windows Server 8 Beta, that number goes up significantly to 32. But again, today it is 4, so just be aware of that as well. Also be aware of things such as CPU bound issues. The way you configure the other settings for your virtual machine in terms of the types of network adapters and so on that you're using could potentially also have an impact on the CPU itself. So make sure that you're actually using the right components. So instead of legacy network adapter, you actually use a network adapter within a virtual machine, which will talk directly to the hardware through the hypervisor and give you better performance than the legacy network adapter, which actually uses the CPU to do all the networking stuff. On the memory side of things, obviously the number 1 rule is make sure you got enough RAM for all the virtual machines in your box. So that's really important. But also to keep in mind that there is a memory overhead for Hyper-V and the hypervisor itself on every single Windows Server box that you're going to enable for Hyper-V. By default, that's 20%, but that can in fact be reduced down using a registry key, and you typically want to keep that to no more than 2 gigabytes of RAM, because that's really all a Windows hypervisor Hyper-V host is going to require to do management stuff. Also, from the standpoint of memory itself, one of the most expensive things that a virtual machine host has to do, so Hyper-V host has to do, and is to map the physical memory in the physical host to virtual memory used by virtual machines. And there's two ways of doing that. One of the ways is to actually use the hypervisor and the memory and the CPU on the physical machine to do that work, or preferably using something called second level address translation or SLAT based hardware. That work can actually be done at the motherboard layer of the physical hardware itself. And all the servers that have been shipped in the last couple of years that I've ever encountered do in fact have second level address translation built in, which just gives you better overall performance within that virtualization environment. In the virtual machine side of things, configure the correct amount of memory for guests. I love that. The correct amount of memory. What is that? It depends. It depends on what is the role of that particular virtual machine. And when you're looking at sizing memory requirements for a virtual machine that's going to run one element of your SharePoint architecture, the rules for doing that are no different than trying to size the exact same piece of your SharePoint architecture to run on physical hardware. So if the recommendation as you're going through and architecting is to have 16 gigabytes of RAM for your query server, well, your virtual machine that you're going to run the query server on should also have 16 gigabytes of RAM. So the rules for architecting a SharePoint environment don't change when you're going physical. It is in fact the exact same thing. But when you do in fact run any workload on a physical host that's in a virtualized environment, there are some other elements that you need to be totally aware of, such as NUMA or non-uniform memory. So I'll talk more about it in just a little while. Also, don't over commit the RAM. So you want to make sure that the total amount of RAM for all the virtual machines doesn't actually exceed the physical RAM available in the host machine, because that's going to cause paging and swapping, which will slow things down as well. Also, if you are in fact running VMware, try not to use memory overcommit, because even VMware recommends not to use that particular feature in production. And if you are using dynamic memory in Hyper-V, make sure that the total amount of memory allocated as maximum RAM for all the virtual machines on a single host doesn't exceed the total physical RAM on that particular host by more than 10 to 15%. Dynamic memory will dynamically allocate and remove RAM to a virtual machine as it needs it, but at the same time you want to make sure the totality of all the virtual machines running on a host is not going to be way above the total amount of physical RAM that physically exists in that particular machine. Now let's talk about NUMA. Basically, in the old days, when we had something called symmetric multiprocessing, you had maybe 2 or 4 CPUs on a particular host that would all share the exact same memory bus and all access this one chunk of memory. And that would be done through something called the North Bridge interface. And what ended up happening is that particular pipe, the North Bridge interface, would be the point that would actually slow everything down, because now every single CPU would have to go through Northbridge in order to get access to memory. So what NUMA does is it now moves the memory closer to the CPU, so the CPUs have quicker access to the RAM. But it also changes the way that the physical architecture of a server is in fact configured so that memory actually now belongs to a CPU, to a physical socket, and other CPUs that need access to that can do so, but that requires a hop across a bus, which is a slower process. So that essentially means that if you have, for example, a 4 CPU server, let's say a server that's got 32 gigs of RAM and it's got 4 CPUs, okay, your NUMA boundary, or the optimal amount of memory to allocate to a virtual machine, is 8 gigabytes. Right? That because you've got 32 gigs of RAM total, evenly distributed across the all the CPUs. It would be 8 gigabytes per CPU. So 32 divided by 4 equals 8. It also means that if you allocate more than 8 gigabytes of RAM to a single virtual machine using a single processor, any thing that requires RAM above that 8 gigabytes will require it to get the RAM from another CPU on the machine, which would actually slow things down. So let me give you a better example of this. Okay, so physical NUMA, you have essentially 2 NUMA nodes, NUMA node 1 and NUMA node 2. In the hardware, at the physical hardware level of that particular server, you've got a 4-core CPU that has some memory allocated to it. You've also got a second 4-core CPU with some more memory allocated to it. And basically, this allows you to kind of scale the number of cores in memory access and gives you a much better performance when a CPU needs to access RAM very, very quickly, because now RAM is very close to the CPU itself. And if you need to get access for more RAM, okay, this essentially means that you're going to potentially have a performance penalty. So high performance applications like SQL Server, for example, as well as Windows Server, will know that they're running on top of a NUMA architecture, and will try and minimize that cross-node memory access and try and keep all the memory within one particular NUMA node, because that is the most efficient. But okay, there's something that is really, really important to understand, in that the way you populate the memory on the physical motherboard of the computer will have a direct impact on how well your NUMA operations work. So here's an example of a really good NUMA implementation. You've got a 4-socket box, okay, which has an equal amount of RAM on every single one of the CPUs, and is done very well. So this is the optimal configuration. The system is balanced, memory allocation and threads allocations are within the same NUMA node, and memory is populated in each NUMA node and is populated in an equal fashion. Typically, when you order a server from a hardware vendor like a Dell or an HP, and you tell them to put in 64 gigs of RAM on your 4-socket box, what they will do is they will populate the memory so that it's equally balanced on all the different NUMA nodes. You'll have 16 gigs per NUMA node in a 64 gig machine, for example. What sometimes ends up happening, and I've actually seen customers do this, is they'll go out and they'll buy a server which may have 4 CPUs on it, but then they'll find that the price of the RAM from the manufacturer is too high, and they'll go to like Kingston and buy a bunch of Kingston RAM and then populate it themselves. And potentially you have something like this, where instead of actually figuring out which memory slots to fill for which CPU, they simply fill the memory slots in one big order, and you get a situation where, you know, NUMA node 1, for example, is fully populated, okay? NUMA node 2 has got 3 out of 4 of the DIMMs in there. NUMA node 4 has 2 DIMMs out of 4. NUMA node 3, I mean. And NUMA node 4 has no memory for it itself. So anything NUMA node 4 does is now going to require a hop to another NUMA node, which is going to be very, very expensive. So the memory allocation and thread allocations use different NUMA nodes. You got multiple NUMA hops. NUMA node 2 has an odd number of DIMMs. Actually says DUMBs, but it really is dumb to do that. NUMA node 3 doesn't have enough, and NUMA node 4 has no local memory. In this situation, any virtual machine you actually implement on top of this architecture is going to perform poorly because their underlying physical hardware is not properly configured. So always make sure that when you purchase hardware and you purchase servers, what you're actually doing is you're making sure that you are in fact configuring the physical memory on the NUMA nodes appropriately. And again, if you're not sure, check the vendor's memory information about how to actually populate memory in the machine. Make sure you populate the right DIMMs at the right time. What you want is that first situation, the totally balanced NUMA infrastructure. In terms of what NUMA means for SharePoint, keeping NUMA boundaries in mind, it typically means that you will get a significantly better performance provisioning 2 SharePoint front-end servers with half the amount of RAM as actually having a big single front-end with twice as much RAM. I'll tell you a story. I did a talk similar to this one about a year ago at a conference, and before I started, one of the people that was attending that particular talk basically says, you know, we're using Hyper-V and I'm having all kinds of problems with my SharePoint infrastructure running on top of Hyper-V. I'm thinking of going to VMware, so you know, hopefully you can tell me something that would actually convince me. I go, you know what? Why don't you sit to the rest of the session and let me know afterwards. We'll have a conversation. Let me know exactly if there's anything there to help you out. So I got to this particular part of the talk, and I talked about NUMA in terms of what it means. And all of a sudden, I could see, you know, his eyes just kind of open completely wide. And I think he just understood that, you know, there was a potential issue with his architecture. And the reality was that they had a server that was a 4-socket box that had 64 gigs of RAM, and he allocated 32 gigs of RAM to one SharePoint component, which was actually crossing NUMA nodes. So that particular virtual machine was running about 30% slower than anything else in his architecture, and he was actually blaming Hyper-V. But the reality was this situation will occur for both Hyper-V and VMware, because it's actually a physical limitation at the hardware level. So it doesn't matter whether you're using VMware or Hyper-V, NUMA is going to be applicable to both. So, you know, to end that particular story, he reconfigured his architecture, reduced the amount of memory allocated to the VMs. All of a sudden, his performance went up, and he was very, very happy to be able to go ahead and do that. In Windows Server 8 Hyper-V, we actually are making a change. So one of the things that we're doing is you actually have the capability to configure virtual NUMA nodes within virtual machines. So this is brand new. I mean, the beta itself has this capability, so you can take a look at it. But I guess we're going to present the NUMA topology of the underlying hardware to the virtual machine, and then actually have that virtual machine be able to take advantage of that as required. So guest operating systems and apps can now make intelligent NUMA decisions about thread and memory. This also means that as you're running SQL Server within a virtual machine, it's got a lot of memory allocated to it. You'll be able to take advantage of the fact that it's running on NUMA and do the right things at the application level within a virtual machine instead of just at the physical host operating system level. Again, guest NUMA nodes are then aligned with the host resources themselves. And again, this is policy driven per host on a best effort, or you can even do a forced alignment of a particular virtual machine to a particular NUMA node. So that's memory. So if there's one thing I do actually want you to walk away with here is that you want to be totally conscious of your NUMA architecture on your server. So understand how many sockets you have, how much memory you've got allocated to that, how those DIMMs are populated, and then understand exactly how much memory you've got on a per NUMA node basis. So when you do in fact create the virtual machines, you're not giving them too much RAM, which is in fact going to cause them to perform poorly. So NUMA is one of those things you want to be totally conscious of. On the disk side of things, it really is really simple. Fast disks are better. At the physical level, have really fast disks. Okay? If you're going to use clustering, use very fast either iSCSI or fiber channel SANs. Slow disks will in fact cause CPU contention as we're waiting on things to execute. So you want to make sure that you have relatively fast disks. And also, don't put every single one of your virtual machines on the same physical disk. Spread them out a fair bit. So put virtual disks on different physical disks than a hard disk that the operating system is on as well. So do not put, if you're using direct attached storage, your OS boot disk and your virtual machines on the same physical disk. Have at least two disks if it's direct, one for the operating system to boot and a second disk for your virtual machines. On the virtual machine side of things, in Hyper-V, we actually support two different adapters, an IDE adapter and a SCSI adapter. The IDE adapter is used for booting. The SCSI adapter is actually preferred for all the rest of the storage because you can also, with the SCSI adapter, add or remove a virtual hard disk at your heart's content. So this allows you to make sure you got good kind of flexibility while the virtual machine is running to add additional storage if you need to. For the virtual disk storage itself, like I said before, when you create a virtual machine in Hyper-V, by default it creates something called a dynamically expanding virtual hard disk, which will grow as required. From a performance perspective in production, that's actually not a good idea. It can be relatively slow if it's going to do a lot of searching on the physical disk to find different portions of that file. So what you want to do is for your production virtual machines, create a new virtual hard disk of a specified size, let's say 30 gigs, and what that'll do is it'll create a physical VHD file on the hard drive, 30 gigs in size at the time you create it, and then all the I/O will be in that one contiguous chunk of memory. So always use fixed size VHDs instead of dynamically expanding VHDs. If you're going to have any disk-bound access, you may want to actually also have the storage for those virtual machines on an iSCSI SAN, because it is possible for a virtual machine to access an iSCSI SAN. It cannot access a fiber channel SAN today in Windows Server 2008 R2, which will actually change in Windows Server 8 down the road. And also make sure that your SAN vendor is aware of the requirements for virtualization of virtual hard disks, and the SAN itself that you have has been optimized for Windows Server 2008 R2 Hyper-V or whatever your virtualization platform happens to be. Because of the network side of things, use the fastest network cards possible, gigabit Ethernet adapters and gigabit switches on the Hyper-V host. On the virtualization server, use server-grade adapters because those are going to have the best overall performance. Desktop adapters used in a server themselves are potentially going to give you slow performance. Add more network adapters as required, so that way if you need to actually have different segments of the network separated out, each of those physical NICs can in fact be allocated to different virtual machines as needed. On the virtual machine side of things, there are in fact two types of network adapters that Hyper-V you can use. One is called the network adapter, the second one is called the legacy network adapter. Don't use the legacy one because that is actually going to do a lot of the work for networking in software and emulation. The network adapter itself is going to talk directly through the VM bus to the hypervisor and to the physical hardware. So make sure that you actually are using the network adapter, which is what are called synthetic drivers which talk directly to the VM bus. And if you want, you can. We do support virtual switches and VLAN tagging so that you can separate traffic onto different VLANs on the same wire. So that's some of the best practices for CPU, memory, disk, and network as well. But one of the other things to keep in mind that's really important in any SharePoint infrastructure is the fact that when you do virtualize any environment, the reliance upon that single physical host becomes much more important. If you're running everything physically, if one of your web front end goes down, that's not necessarily a big problem. Or if if one of the elements goes down, it's just going to affect that particular thing. But if you're virtualizing your SharePoint architecture and the one host is running your web front end, a query server, potentially a database role, and so on, and the second one is running other elements, if one of those physical hosts goes down, what ends up happening is your SharePoint infrastructure gets much more impacted. So you want to make sure you protect your SharePoint infrastructure, but also the host that they're running on. So from a high availability perspective, in Hyper-V, the key thing to implement here is failover clustering. Failover clustering allows you to have your virtual machines run on the cluster and then be migratable very easily between different nodes in that cluster. And should a single node actually fail, so if one of those hosts goes down or has some kind of catastrophic failure, the workloads, your SharePoint architecture then is started up automatically on the other nodes in that cluster, and your downtime is minimized to typically less than a minute. Right? So it gives you things like hardware health detection. If it's a hardware problem, we'll detect it. Host operating system health detection. If the operating system that your Hyper-V host is running hangs or has some issues, the cluster will detect that as well, and then restart the workload on a different machine and reboot the failed node. Also, you have the capability to monitor the operating system in a virtual machine, so virtual machine health detection. So if one of your virtual machines running parts of your SharePoint infrastructure hangs, if the OS hangs, we'll restart that virtual machine to get it back up and running. As well as things like application service and health detection. And again, we do have automatic recovery, and also the capability to move virtual machines from different hosts, so that what actually ends up happening is if you need to patch a host because Patch Tuesday just happened, you can use live migration to move all the virtual machines from one host to another, patch that host, reboot it, move the virtual machines back, and at no point in time would anybody out there that's using your SharePoint infrastructure even know that anything has actually happened, because we'll make sure that through live migration their connections to your SharePoint infrastructure are never impacted. Really, it's a way to make sure you don't keep all of your eggs in one particular basket. Okay? For SharePoint itself, we actually have two different elements of clustering, right? So in a Hyper-V world, we have something called live migration and host clustering, as well as guest clustering. Host clustering is a term that we use when the virtual machines are running on Hyper-V hosts, and should anything happen, when that host fails, the VMs will get restarted on a different host. Or we can live migrate, i.e. live move, very similar to VMware's vMotion, a virtual machine from one host to another without actually having any particular issues. In both cases, clustering does in fact require shared storage. So you want to make sure that you got shared storage, either a fiber channel or an iSCSI SAN, and this will allow you to be able to move those virtual machines as required. Guest clustering means you can actually create a cluster between two virtual machines. This is actually very useful for SQL Server, for example. So you create a cluster between two virtual machines. Within those virtual machines, you have direct access to iSCSI storage to store the SQL Server data, for example. And you can move the SQL Server role from one virtual machine to another, so one node in that cluster. And should anything actually end up happening, the other virtual machine will take over. But also, it's a really easy way to be able to patch the guest operating system, so that operating system running within a virtual machine, or if you need to patch SQL Server, for example, you can patch SQL Server on one of the virtual machines and then fail it over to the other one, and then patch that second one, and so on down the line. So this gives you a really good way of ensuring you get good availability. And it's also possible to have a combination of the two as well. Okay? So what clustering actually gives you from an availability perspective, it avoids having a single point of failure when consolidating your environments. Okay? So the virtual machines will survive a host crashing. So if the host that it's running on crashes, the VM will be restarted on another node in the cluster and will continue to work. If the VM itself crashes, so if the virtual machine operating system crashes or hangs, we'll restart that particular virtual machine on the exact same node. If the VM itself, basically there's zero downtime for maintenance and patching as well. So if you want to actually patch the host, you live migrate their virtual machines to another node, patch that host and reboot. And also the other nice thing is through live migration, you can now also easily distribute your virtual machines across different servers in a cluster to get a more load balanced overall implementation and one that performs better. Clustering is something that you definitely want to do in any SharePoint environment, and it's applicable to any SharePoint server roles at all. Okay. Guest clustering itself, like I mentioned before, gives you the capability to have clusterware applications now run within a virtual machine. So this also will monitor the health of that application. So if your SQL Server instance, for example, has an issue, clustering will take care of that. It'll restart SQL Server on the other node. It also lets you move that SQL Server instance from one virtual machine to another while you're patching it or while you're maintaining a server or anything along those lines. Again, this is ideal for SQL Server in a SharePoint environment. You can also combine the two. So it is possible to have a situation where your virtual machines are part of a guest cluster, but within the virtual machines themselves, you've actually got, part of a host cluster, and within the virtual machines themselves, you've got a guest cluster for SQL Server. So the host clustering takes care of being able to move the virtual machines around different hosts, and the guest clustering takes care of being able to move SQL Server between the different virtual machines. The one thing I will strongly encourage you to do if you're going to go ahead and do this, and this does work, I've seen this, I've implemented this, document it. It's not for the guy that's going to come after you trying to figure out what you've done. It is for you 3 months down the road as you're into 3 different projects or 4 different projects after you've done this, trying to figure out when you go back to it, what the heck did I do? So always document this because it is a little bit more complex to architect this and to be able to understand what's going on. But if you document, you should be fine. So don't forget to document your architecture as well. Okay. Now, the other thing to keep in mind is when it comes to which particular hardware should I use for failover clustering and so on, obviously the best requirement or the best practice is to have identical hardware in all the hosts, so that every single one of the machines that are part of a host cluster are in fact in the exact same configuration, same manufacturer and so on down the line. That is strongly recommended. Actually not required, but it is recommended. The only requirement we have in order to support you for clustering is that as you create the cluster, as you make changes to it, you run what we call the validated cluster configuration wizard. And if you do in fact pass validation, so if you have no errors in validation, everything passes, no matter what that hardware is, as long as the hardware is supported for Windows Server 2008 R2, your cluster is also fully supported. And that's different from the old days in Windows 2000, for example, where we had a separate set of hardware for clustering versus for running Windows 2000. Today, if it runs Windows Server 2008 R2 and is certified for that, and you pass validation, you are supported to run this on a cluster. So commodity hardware, nothing special. It's that simple. It all works very easily. Okay. The other thing that you can also keep in mind is in a situation where you have things like multiple front ends, because you always want to have multiple front ends that are load balanced, you also want to make sure that those front ends or even different nodes in a guest cluster are going to be running on different hosts so that a single host failure is not going to impact the entire environment. So there is this registry entry called the antiaffinity class names property, which allows you to basically have machines with the same AACN or antiaffinity class property being on the same host. We're going to try and keep them off the same host, so it's also a great way when a cluster starts up to do load balancing. So, if we have 4 virtual machines in that particular cluster, when the cluster starts up, those 4 virtual machines will get evenly distributed across the 4 hosts. When we've got 6 virtual machines, maybe that are doing network load balancing for a web front end, well, we'll put 4 on different hosts, but because there's 6 and there's only 4 hosts, we're going to put the other 2 on other hosts, like on the host that there's already another one there. And that is because the preference here is to make sure that that virtual machine is running as opposed to separate from another one. And if some of these hosts fail, you may get other doubling up, but that's okay because what we're going to try and do is distribute those virtual machines as evenly as we can across the different hosts. So it's really, really a good thing to keep similar VMs off the same host, guest cluster nodes, web front ends, and that kind of stuff. The other thing to keep in mind with regards to availability on the SQL Server side of things is that, again, database mirroring is fully supported in SharePoint 2010, but if you're using file streaming to actually offload the blobs onto NTFS partitions instead of having them within SQL Server, database mirroring is not supported, but clustering for high availability in SQL Server is supported at all times. In terms of disaster recovery, again, for SQL Server, because it's so important in the SharePoint architecture, things like lost shipping are an easy way to set up a DR scenario so that if anything does happen, for example, you could easily go to that. And also things like System Center Operations Manager, Virtual Machine Manager, and other System Center tools will allow you to actually create that DR scenario relatively easily. Okay. Just very quickly talking about VMware. Okay. One of the things that I do want to point out is that when you're looking at overall scalability, one of the things that Hyper-V often got mentioned by VMware on is the fact that we're not necessarily scalable. We haven't got a lot of enterprise level scalability. When you think that a website like Microsoft.com is fully virtualized or running on Hyper-V, I kind of have a hard time believing that. But also when others like Target stores virtualize their entire infrastructure on Hyper-V today, obviously we feel we've got some great chops with regards to enterprise scalability. But also keep in mind that as we release Windows Server 8, those limitations that we had in earlier releases do in fact go away. So for a number of logical processors on a Windows Hyper-V box in 2008 R2 is 64. In Windows Server 8 beta that goes to 160. The amount of physical RAM in a box today is 1 terabyte. In Windows 8 it's going to be 2 terabytes. The number of virtual machines running in a cluster is 1,000 VMs on a 16-node cluster. In Server 8 it's going to be 4,000 VMs in a 64-node cluster. Today we support 4 virtual processors per virtual machine. Windows Server 8 beta it's up to 32. Virtual machine memory per VM is today 64 gigs. Windows Server 8 is 512 and so on down the line. So there's a lot of things that as Windows Server 8 becomes more widely available and as we actually release that product, you're going to find all these limitations do in fact go away. From the cost perspective, I mean, to create a highly available cluster with live migration capability that's very similar to vMotion on Windows Server 2008 R2 today. I mean, basically all that's available for free in Windows Server 2008 R2 Enterprise or Data Center Edition, and also in the free Hyper-V server. For the VMware on the vSphere side of things in vSphere 4.1, there is obviously a cost associated to it. Plus, you also still have to buy the Windows licenses. Okay? Also, to keep in mind that VMware vSphere itself is not just Windows Server 2008 Hyper-V. It is Windows Server 2008 R2 Hyper-V and System Center together. And on the System Center side of things, we've got a lot of great products as well that we're releasing. And even when it comes to vSphere 5, again, our pricing with regards to integrating System Center as well as Hyper-V and Windows licensing was significantly cheaper than VMware vSphere 5 at the exact same time. So, your key takeaways for this particular session. Okay? Very, very straightforward. Okay. On the best practices and recommendations for virtualizing SharePoint, when you create your virtual machines, configure a one-to-one mapping between virtual processors and physical processors just to make sure that you've got the best overall performance. Allocate sufficient amount of memory to each VM based upon its requirements. So front ends typically are going to require less RAM than something like an index server or a SQL server, so just be aware of that. Make sure you use the fastest overall disk architecture and use fixed size VHDs for the virtual machines that will actually give you the best overall performance. You can use VLAN tagging in network for security, and again, always associate the SharePoint VMs with the same virtual switch on the machine. Ensure you got the most recent edition of the integration components, which are similar to VM tools on the Hyper-V side of things. Don't use your Hyper-V host, your virtualization host, for other roles. Don't make them a DNS server or a DHCP server. Make them a Hyper-V server, and if you can, use a server core edition, which has a much smaller footprint and is potentially better performing. And again, load balance your virtual machines across multiple hosts and implement failover clustering as much as possible. Really, really important stuff. Understand what your virtualization vendor's feature set is, whether that's Hyper-V or VMware. Understand what they offer. Don't forget to do the SharePoint things, right? Governance, SharePoint architecture, the way you do things properly still apply. So always do the right things from the SharePoint perspective. For SharePoint virtual machines, do not use snapshots in Hyper-V environments. They are not supported. The reason being is that because SharePoint has so many different server roles, if you create a snapshot on one, it may actually not work properly if you bring that snapshot back because the other is not at the same level. Don't put too much stuff on one host server. Distribute the load as much as possible. If you're using Hyper-V's dynamic memory, don't ever allocate the total amount of maximum RAM for all virtual machines to more than 10 to 15% of available physical RAM. And keep in mind that your virtualization host, whatever it is a single point of failure, so protect it. Protect the VMs running on it. Use clustering as a great way to be able to go ahead and solve that. Even more important stuff, don't fight SharePoint. You'll lose. Do the SharePoint stuff. Okay? Virtualization is a great way to cut costs and consolidate equipment and take advantage of hardware resources in a very, very efficient way, but also make sure you're doing the right things and make sure you understand your hardware feature set as well. Always plan for availability. Make sure that your environment is going to continuously run as well, and always measure performance over time and adjust as required in terms of where to put those virtual machines as your SharePoint environment evolves. Okay? Next steps, again, you'll be able to get the slide deck as well off the Tech Days CA website. Download System Center 2012 eval software to understand how that actually works. Really great resource for you to take a look at to learn more about virtualization is MicrosoftVirtualAcademy.com. Has a lot of online courses to teach you more about virtualization and Hyper-V in particular, but also allows you to understand how these environments work. If you haven't already yet, download Windows Server 8 Beta and give it a try in that particular environment. So test it out in your lab, but definitely implement 2008 R2 today. Again, resources, the slide deck will be available, so you can click on all these things, but there are great resources for how to virtualize SQL Server, how to virtualize SharePoint 2010 in a little more detail there as well. And with that, I thank you so much for taking part. Again, objectives here that hopefully I got across is virtualization. There's some performance best practices that you need to be aware of, as well as some high availability considerations. Hopefully I talked through some of those. If you have any questions, let me know. And again, keep in mind that every single SharePoint role can and should be virtualized, and SharePoint with clustering can in fact increase availability of your environment as opposed to decrease it. And with that, I'll take any questions in the next little while. Thank you very much for participating, and thanks a lot. Bye-bye.